We talked about zero and negative exponents in pre-6. We're just going to review that first. For any non-zero number, which let's just say a, okay, a to the 0 equals 1. Anything to the 0 power is 1. 0 to the 0 doesn't exist. And then here are two examples. We've got 4 to the 0 is 1, and then in algebra, a to the 0 equals 1, as long as a isn't 0. Negative exponents, for any integer n and any non-zero number a to the negative n equals 1 over a to the positive n. And we've got our numbers example, 4 to the negative 2 equals 1 over 4 to the positive 2. And then here's what we wrote in algebra, as long as a isn't 0, because you can have 0 in the denominator as a base. So let's just do some quick examples. We have to evaluate each expression. So 6.7 to the 0, anything to the 0 is 1. And then letter B, negative 2 to the negative 4th power. That means 1 over negative 2 to the positive 4th. And because we can actually do negative 2 to the 4th power, right, because that would be negative 2 times negative 2 times negative 2 times negative 2, we're going to simplify that and say 1 over, that would be 16. All right, let's try a little more complicated example. Example 2. We have to simplify 4x to the 0 over y to the negative 3, and we have to write our answer using only positive exponents, which mean our final answer cannot have a negative exponent in it. So, the first thing to recognize is that anything to the 0 is 1. That doesn't make the whole numerator 1, it just means it's 4 times 1, because x to the 0 is 1. So it's 4 times 1. Now, well, I should use parentheses because that looks like 4.1. Now what I'm going to do is look at this negative exponent. I'm not allowed to write my answer with negative exponents, so the way that we simplify it is negative exponents mean to do the reciprocal. What that means if you already have a fraction is that if it's in the denominator, it moves up into the numerator, and if it's in the numerator, it moves down to the denominator. So I have y to the negative third in the denominator, which means the reciprocal is going to move it into the numerator. So what that's going to turn into is 4 times 1 times y to the third. And then since there's nothing on the bottom, right, it would just be 1. So let's just simplify that. 4 times 1 times y to the third is 4y to the third. Now there are 3 more rules of exponents that we're going to look at right now. When you have a multiplication question, so this is called product of powers, so this is a product of 2 different powers, as long as they have the same base, you can add the exponents. So let's fill in the blank up here. To multiply powers with the same base, you add their exponents. And the reason that you can do that is because this is 4 6 times, and this is 4 3 times, and so essentially what you get is 4 9 times. Cool. Let's look at the quotient of powers property. The quotient of powers property is essentially the reverse of that. So if you have division, to divide powers with the same base, you subtract the exponents. So if we look at this example, we've got 4 to the 6th over 4 to the 3rd, and that gives us 4 to the 6 minus 3, which is 4 to the 3rd. Here's why that works. You've got 6 4s on the top and 3 4s on the bottom. And then if there's a factor on the top that's also on the bottom, you can cross them out. And so then you can see you're only left with 3 4s. It's a pretty cool technique. And then the last thing is that we have the power of a power, which means you have a power, an exponent, being raised to another exponent, and then you multiply. So to find a power of a power, multiply the exponents. And why that works is you have 4 6s. And what does it mean to raise something to the third power? It means to write it 3 times. So you have the same thing 3 times, kind of annoying to write out. But what that means is then you end up having 4 to the 18th because you have 6 3 times. Now there's a cool acronym, MAD-SPAM, and MAD-SPAM stands for multiply, add, divide, subtract, and PA stands for parentheses, because if you see up here we have parentheses, so parentheses, you multiply. And so if it's helpful, you can remember MAD-SPAM to remember the rules. All right, let's use those rules. So we've got 3 to the second times 3 to the sixth. Since this is a multiplication question, we're just going to simply add the exponents. So it'd be 3 to the 8th. For this question, it's a division, and division you subtract. So it's -4. You have to keep those parentheses to the -5. Oh, but it says we can only use positive exponents. So remember, negative exponents mean to do the reciprocal. So then what we have is 1 over -4 to the 5th power, and we can calculate that. -4 times -4 times -4 times -4 times -4. Probably need a calculator handy. The pause was me getting my calculator out. And it's -1024. And then the last one, we have parentheses. That's multiply the exponents. So this gives me z to the -12. And again, I can't use negative exponents in my answer according to the directions. So it's 1 over z to the +12. Since I don't know what z is, you can't do z to the 12th, so you just leave it. So those are the basic ones. I know you're like, what, basic? But then we have a little more complicated ones. Next one that we're going to look at is the power of a product property. And that's when you have a product, a multiplication question, and then you're raising that expression to a power. And what you do is you find the power of each factor and multiply. So what I'm going to do, for example, in this numbers example, is I have 3 times 2 to the 5th, which you could write as 6 to the 5th, but that's not always easier. Just go with me. What you would do is you would do 3 to the 5th times 2 to the 5th. So it's kind of like the distributive property in a sense. So now we've got a similar skill. We're going to look at a quotient, which is a division problem. So you can see in this example, we've got a division. And the way that you do that is you find the power of the numerator and the power of the denominator, and then you divide. So you look at this example, and you might say, why can't you just do 1.5 to the 5th? And you could, but that doesn't always make it easier. What we're going to do here is do 3 to the 5th divided by 2 to the 5th. And so again, it's kind of like the distributive property. You're taking each piece and raising it to that power. So now when we scroll to look at some examples, we're going to take each piece and raise it to that power. So in letter A, we're going to take 1.5, -1.5 and square it, and y and square it. So I'm going to write out the steps. We would do -1.5 to the second times y to the second. 1.5 times 1.5 is not 3. -1.5 times -1.5 is positive 2.25y squared. In letter B, we're going to do a to the third over negative 10 to the third. Be careful to put those parentheses because negatives need to go in parentheses. And this gives you a to the third over negative 1,000. Now in letter C, we have two pieces in the numerator. So it's going to be 3 to the fourth times d to the fourth over 2 to the fourth. Every piece goes to the fourth. So now we do 3 to the fourth, which is 81, d to the fourth, over 2 to the fourth is 16. If we could, we would reduce 81 over 16 like a fraction, but since it doesn't reduce, we just leave it. Now, letter D is pretty complicated, but I'm going to give you a pro tip right now. My pro tip is to flip the fraction before you take each piece and do that distributive skill. So the first thing that I'm going to do is do 3 over 2x to the fifth. It's easier to distribute a positive exponent than it is a negative exponent. Now, I'm going to distribute in a sense. 3 to the fifth over 2 to the fifth, x to the fifth, and 3 to the fifth. I'm not sure what that is off the top of my head. That pause is me getting my calculator. It's 243. 2 to the fifth is 32. X to the fifth, and 243 over 32. I've already checked. It doesn't reduce. All right, let's see how this plays out in a word problem. We've got a volume of a cylinder, and remember the formula for volume of a cylinder is pi r squared h. And they want us to say which expression shows the volume of a cylinder. So I'm going to take my formula and I'm going to plug in what I know. The radius, according to the picture, is h over 2, and the height is h. So let's just simplify. That is h squared over 2 squared times h, which then gives me h to the third over 4. So it is this one. All right, let's check out one more. A jellyfish emits about 1.25 times 10 to the 8th particles of light or photons in 6.25 times 10 to the negative 4th second. So this is written in what we call scientific notation. How many photons does a jellyfish emit each second? So what I want to do is I need to do photons per second. So you should have done scientific notation in the red book. We're going to do photons, which is 1.25 times 10 to the 8th divided by 6.25 times 10 to the negative 4th. So what I'm going to do in this example is I'm going to divide these numbers and I'm going to divide my powers. So 1.25 divided by 6.25 is 0.2. And then 10 to the 8th divided by 10 to the 4th is subtract the exponents, 10 to the 12th. So that's not written in scientific notation because this number right here is not between 1 and 10. So I'm going to move my decimal point over 1 to the right. And then that's going to shift down to 10 to the 11th because I don't need to move it 12 times now. Now I only need to move it 11. And in standard form, because it wants that 2, standard form would be 2 followed by 11 zeros. If you need more practice with well, I guess I should put the label. That's photons per second. If you need more practice with scientific notations, please ask in class. That is an 8th grade skill. It's something that you should have done in your extra chapters from last year. And if you have any questions, write them down and ask me when you come to class.